Good morning, students. In the previous class, we actually discussed our chapter number 2, physical quantity and measurement. In this chapter, we discuss about density, okay, SI and CGS units of density and their relations. Also discuss about how to measure density of regular shaped body with the help of different formula, and also we actually measure density of irregular shaped body with the help of measuring cylinder. Okay, now today we are going to discuss about our next part, that is discuss about determination of density of a irregular solid using eureka can. Okay, here you can see actually, here you can see this is eureka can. Okay, in this system the same process is actually following. So first one is find mass using a beam balance, second one is find volume using eureka can, then find density using the relation mass per unit volume, or density D equal to mass divided by volume. Now the question is how we measure the volume of the irregular shaped body with the help of eureka can. First we just fill the actually eureka can with the water up to this mark. Okay, up to this mark, then we just immerse the body, okay, irregular shaped body in the liquid or in the water. Then the displaced water, actually the displaced water is taken into the measuring cylinder. This is the volume of displaced water. Okay, you can see this is the volume of displaced water. So here the volume of the displaced water is equal to the volume of the irregular shaped body. So in this way we can easily find out the volume of irregular shaped body, and we easily find out mass of body with the help of any beam balance. Okay, then we just use the relation P is equal to m by v, and we can easily find out the density. So this is the application of eureka can. Okay, in this way you can actually find out volume with the help of eureka can. Here we take actually one example, one question, that is an irregular shaped body of mass m is given, that is 250 gram. Okay, 250 gram is put in eureka can, and water displaced in collect in measuring cylinder in which water is already at mark 20 centimeter cube. Now the water level rises to 60 centimeter cube. Now at first calculate volume of the body. So first the volume of the liquid or water, that is taken 20 centimeter cube. After putting the irregular shaped body inside the actually liquid, we get some rise in water, that is up to 60 centimeter cube. Now what is the volume of the body? Simple, volume is equal to 60 minus 20. This is the volume of displaced liquid, actually displaced water by irregular shaped body, that is equal to 40 centimeter cube. Now this is first question, question number A, and the second question, find density of body in CGS and SI unit. Okay, here you can use density D equal to mass by volume. So D is equal to m upon V. M is given, that is 250 divided by 40, that is equal to 25 by 4. Okay, or you can take as 6.25 gram per centimeter cube. And also in SI system we just know the relation between SI and CGS unit of density. So in SI unit actually we just write down D is equal to 6.25 into 10 to the power 3 kg per meter cube. Okay, so I think all of you understand the problem. See, actually simple formula D is equal to m by v. So we just use the relation and find out density of this irregular shaped body with the help of Eureka can. Now we move to our next portion, that is determination of density of a liquid. Okay, not solid. Now we have to determine of density of a liquid with the help of density bottle. You can see in the right side, this is actually density bottle. Okay, and the volume of the density bottle actually 50 ml. Okay, so inside the density bottle 50 ml actually space is there. So here you can see this is glass stopper and this is one hole, okay, in the glass stopper, and this is made by a glass. Now how we actually find out density of any liquid with the help of this density bottle? Simple. At first we measure the mass of density bottle without liquid, any liquid. So first we find out mass of density bottle with the help of any physical balance, and we take as the mass of density bottle without any liquid, that is m1. Okay, now fill the density bottle up to volume mark. Okay, this is actually volume mark. Okay, up to this mark we just fill the density bottle with some liquid, and we again measure the mass of the liquid density bottle with liquid and density bottle with. So in this case we get actually the result is m2. So now what is the actual mass of liquid? Simple. Mass of liquid is equal to, here you can see, mass of liquid is equal to m2 minus m1, because m2 is the mass of liquid bottle with, liquid plus density bottle, and m1 is the only mass of density bottle. So from the difference we can get mass of liquid, and also we know the volume of liquid because the volume that is given 50 ml. Okay, so inside only 50 ml liquid is filled up to this mark. Okay, so we just use the relation and we get density is equal to m2 minus m1 divided by v. V means actually volume of the density bottle. Okay, so with the help of this density bottle we can easily find out any actual density of any types of liquid. Now we move to our next portion, that is very important, that is relative density. In generally, what is actually meaning of relative density? Relative density is the ratio of the density of a substance to the density of water. Basically it is the ratio of two density. One is density of substance to the density of water, and it is usually measured at room temperature, that is 20 degrees Celsius, and standard atmospheric pressure. Okay, and that is given. Okay, now it is also known as specific gravity also. Okay, relative density is known as specific gravity also. Here you can see mathematically relative density is equal to density of a substance divided by density of a water at 4 degree Celsius. Now as it is the ratio of two density, so it is unitless. Okay, so relative density actually unitless quantity. Now we know that what is the meaning of density. Density means mass divided by volume. So now if we take in terms of mass and volume, then what is the relation? The relation is density, relative density is equal to mass of the substance divided by volume of the substance upon mass of the water divided by volume of the water. Now if actually volume of substance is equal to Vs is equal to Va of water, then we can say that Rd is equal to only mass of substance. Okay, mass of substance divided by actually mass of H2O water. Understand? If we take for both cases volume is same, that means volume of substance is equal to volume of water, then we can say relative density is the ratio of mass of the substance to the mass of the water. Okay, here we take an example. Specific gravity is the ratio of the mass of a substance to that water. Okay, because we take here, okay, in CGS system volume is equal to the density of water. That's why we can write down this. Okay, and also you notice that specific gravity is a ratio. That's why it is actually does not have any unit. Okay, and in this case, if this is very important, the specific gravity of a substance, okay, will let us know if it will float or sink. Suppose for one substance relative density is greater than 1, that means it will sink in water. Okay, otherwise if relative density is less than 1, then it will float. So you can say if RD greater than 1, that means the body actually sink in the water, and if RD less than 1, then it will float also. Okay, so this is the quantity, that is relative density. Now we move to our next part, that is determination of relative density of a liquid using the density bottle. Okay, at first we just find out density of a liquid using the density bottle. Now we have to find out relative density of a liquid with the help of density bottle. At first we just find out mass of empty density bottle, that is by physical balance, that is suppose we take m1 gram. Now we just take some actually take water, okay, inside the density bottle, and we again measure the mass of water with density bottle, that is m2 gram. Now again we measure the mass of density bottle with the another liquid that is given, or the density actually whose relative density have to measure, we have to. So we just use the liquid, unknown liquid, okay, with density bottle, and again we measure the mass by physical balance, and we get result m3. Here you can see m2 is the mass of water with density bottle and m1 is the mass of empty density bottle. So from the difference we can easily find out mass of water m2 minus m1, and m3 is the mass of liquid with density bottle. So m3 minus m1 is the mass of liquid. So from this case we actually with the help of density bottle we actually find out mass of water and mass of liquid individually. Okay, now for density bottle, for both cases volume is same. Okay, so in the previous slide I actually tell you if volume is same, then RD is equal to ratio of mass of substance with mass of water. So you just put it and find out relative density. Relative density is equal to m3 minus m1 divided by m2 minus m1. Here remember that volume of liquid and water is same, that's why we use the relation m3 minus m1 divided by m2 minus m1. Okay, so in this way you can easily find out relative density of any liquid with the help of density bottle. Now again we take one numerical problem, that is a 250 centimeter cube bottle of oil has a net mass of 189 gram. Calculate its density at first, then relative density of oil, and state whether oil will float or sink in water. So first m is equal to 189 gram is given, volume is also given 250 centimeter cube. In both cases they are in CGS system, that means density is equal to m by v. We just put the value 189 divided by 250 centimeter cube and we get 0.756 gram per centimeter cube, and relative density means density of oil divided by density of water, and we know density of water in CGS system is 1, that means relative density is equal to 0.756. From this case you can see relative density of oil is less than 1, that means it will float in water. Okay, because in the previous slide I actually discussed that relative density greater than 1 means sink, and relative density less than 1 means it will be float. Okay, now we move our next part, that is what is the difference between density and relative density. Here you can see we already discussed the two quantity, that is first one density and second one is relative density. Okay, so first one density means it is defined as the mass per unit volume. Okay, and relative density, it is defined as the ratio of density of the substance to density of water at 4 degree. Okay, for density actually it is different in different unit system. Okay, if we find out density of any body in CGS system and SI system individually separately, then we get different result. Okay, but for relative density its value is the same in all system of measurement. Okay, and density, for density its units are gram per centimeter cube in CGS and in SI kg per meter cube. But relative density, as it is the ratio of two density, so it has no units. And this is actually the difference between density and relative density. Again, from this figure you can actually relate. Okay, relative density is equal to mass of any volume of substance divided by mass of an equal volume of water. Here you just, okay, remember the line equal volume of water. If the volume of water is different with the volume of substance, then we cannot write the relation. Okay, so if we take for both case substance or water, the equal, we take same equal volume, then we can write down the relation. Here you just see, we take two example. First one for steel. Okay, and for steel actually in SI system the density of steel is 7800 kg per meter cube, and for water 1000 kg per meter cube. So relative density for steel is 7.8, that means it is greater than 1. That's why steel will sink in the water. But if we take wood, then its actual density in SI system 500 kg per meter cube, and for water 1000 kg per meter cube. That means relative density we get 0.5, that means it is less than 1. That's why actually wood will be float in water. Okay, and here you can, in the right side you can see another example or a numerical problem. Calculate the density of a material has a mass of 0.052457 kg and a volume of 13.5 centimeter cube. What is the relative density of the material? Here at first you just find out density of the material. Mass is given in gram and volume is also given in centimeter cube. So we just convert centimeter cube into meter cube. Okay, and we get the volume of the material in SI system in meter cube. Okay, and we just use the relation. Here actually it is given in kg. I think this is wrong. Actually it is kg. Okay, so that's why we just convert volume of the material in SI unit. Okay, so now we just put density equal to mass upon V volume, and we get the density in SI system approximately 3890 kg per meter cube. Again we just use relative density is equal to density of material divided by density of water, and we get relative density is approximately 3.89. It is also greater than 1. Okay, and again you can see the material will sink in the water. Okay, so from these problems you can understand water floating and sinking. Water floating and sinking. So first, actually if the object is more dense, okay, if the density of object is greater than density of water, that means relative density is greater than 1. That's why the body will sink. Okay, so if the object is more dense than water, it will sink and when placed in water, and if it is less dense than water, then it will float. Like example, you can actually take an example. An iron nail sinks in water while a flat cup floats. Okay, and this is because the nail is actually unable to displace the amount of water equivalent to its weight. Similarly, an empty plastic bottle floats in water. However, when you fill it up with water, the bottle sinks. Okay, so before going to the example, okay, before going to explain the example, at first we have to know the principle of flotation. Already one point is discussed, that is relative density. Okay, now we just going to the principle, that is the principle of flotation states that when an object floats on a liquid, the buoyant force that acts on the object is equal to the weight of the object. Okay, so in generally, when an object floats on a liquid, or actually an object wants to float on a liquid, then some force that is acted on the body in upward direction by the liquid, that is called buoyant force. The buoyant force that acts on the object is equal to the weight of the object. Okay, so at first the displaced volume of liquid is equal to the volume of object which is immersed in the liquid. If the weight of the object is greater than the upthrust, then the object will sink in the fluid. And if the weight of the object is equal to the upthrust, then the object is balanced, making the object float. Here you can see three figures. From this first figure, you can see actually this portion is just below the water level. So that means here you can see from this case the upthrust that is given by liquid, that is greater than the weight of the floating body. Okay, that's why the body will float. Okay, and also you can see actually the displaced water by the lower portion. Okay, the weight of the water by the lower portion is greater than the whole weight of the body. Okay, for second case, actually the weight of the body is greater than the weight of the displaced water. Okay, and for third case, it will also, you can say, actually equal. The weight of the body is equal to the weight of the displaced water by the body. So if weight of the displaced water is more than the weight of the whole body, then it will float. Okay, if weight of the body is greater than the weight of the displaced water, then it will sink. Okay, here you can take an example. Okay, for first example, you can take an iron nail sinks in water while a flat cup floats. Okay, so here if it is iron nail, then you can say that the weight of the displaced water is less than the weight of the iron nail. That's why the iron nail sinks. Okay, but if we take a flat cup, then the weight of the displaced water is more than the weight of the flat cup. That's why flat cup floats. Okay, and here you just take one difference that is very important. The density of an object determines whether it will float or sink in another substance. An object will float if it is less dense than the liquid it is placed, and an object will sink if it is more dense than liquid it is placed in. Okay, already that is discussed. Okay, and the next one is laws of flotation. Okay, when a body floats with its volume partially above the liquid surface, the volume of the liquid displaced by the body is equal to the volume of the submerged portion of the body. Since the body is in equilibrium, the force of buoyancy acting on the body must be equal to the weight. Okay, that is known as the laws of flotation. And we have to know Archimedes principle, that is based on laws of flotation, when a body is wholly or partially immersed in a liquid, it appears to suffer a loss of mass equal to the mass of fluid it displaces. Okay, already laws of flotation actually discussed in this figure. Okay, in this figure we just discussed. Okay, in generally you have to remember, okay, when we actually immersed a body inside a liquid, then the submerged or immersed part of body actually in the weight of, sorry, the volume of the actually displaced water is equal to the submerged part of any body. Now the volume, sorry, the weight of the displaced water actually acts or apply one force, that is buoyant force or upthrust on a body. If weight of the liquid, displaced liquid, is equal to the weight of the whole body, then it will float. Okay, equal or less than, or weight of greater than. And if weight of the body is greater than the displaced liquid, then it will sink. Okay, here are the some applications like floating of ships. Okay, floating of man, submarines, icebergs floating on water, swimming. Okay, hydrogen or helium filled balloon rises in water. All these actually cases are based on the laws of flotation. Okay, for all cases actually, if it will be float if weight of the displaced liquid or gas, okay, is more than the weight of the body, then it will float. Okay, so this is the end of today's class. In the next class we discuss the next part.